Welcome to Dr. B.R. Ambedkar Open University. Today we are discussing about geometric distribution. It is in the part of B.Sc statistics in third semester. What is geometric distribution and how it will be useful in your real life and how to use the formulas, and we can learn the theoretical part in geometric distribution. So in the geometric distribution, what is the objectives? Define geometric distribution. Find the mean and the variance of the geometric distribution. Define the MGF, moment generating geometric distribution. Calculate the probability geometric distribution. These are the objectives. Suppose we have a series of independent trials of repetitions, and on each repetition or trial, the probability of success P remains the same, then the probability that X is failures. Preceding, the first success is given by the power of x cube. What is the definition of geometric distribution? A random variable x is said to have a geometric distribution if it assumes only non-negative values. Non-negative value means negative values means minus, non-negative values plus, and it is probability mass function PMF is given by the formula P of capital X is equal to X. So P into Q power X, X is equal to 0, 1, 2, 3 and so on. So 0 otherwise. The condition is 0 less than P less than or equal to 1. Here P x is equal to x greater than 0 and summation of x is equal to 0 to infinity P x is equal to x equal to summation of x is equal to 0 to infinity P into Q power x. So see here P x is equal to x and that is equal to P into Q power x we are writing here. What is the formula I am telling here? P into then expanding we are here 1 plus Q square plus Q plus Q power 4 and so on. The 1 plus Q square and so on we are writing in the next step P into 1 minus Q whole power minus 1. So 1 minus Q whole power minus 1 we can write in the next step P into P power minus 1. The basic fundamental formula here P plus Q is equal to 1. So P into P inverse. So P inverse means it is a division by 1 by P. P by P is equal to 1. The value is 1. Then another definition also here. Suppose a discrete random variable x as the following probability mass function we can write here PMF. P x is equal to k and Q power k into P, that is also we can write here 0 less than k less than infinity. The x is said to be geometric distribution with a parameter P. Without parameter P, we do not do the geometric distribution here. So usually this developed the replacing having a child of Bernoulli experiment and having a girl a success, I could have used coin flips. The geometric distribution is a special case of negative binomial in the case r is equal to 1. So it is important we give the special treatment. So motivating, what the motivating example, we can take the one example here. Suppose a couple decides to have a children until they have a girl. Suppose the probability of the having girl as P. So, దంపతులు ఇద్దరు కోరుకుంటున్నారు అమ్మాయి కావాలని. So we can let x is equal to number of the boys and the precede the first girl. So మనం కావాలనుకున్నప్పుడు దాన్ని మనం ఇక్కడ ఎక్స్పెక్ట్ చేస్తున్నాం మనం. Find the probability distribution of x. First we can treat here x could have any possible whole number value, that is 10 lakhs is very unlikely. So we can take here Px is equal to k, P is equal to B and G. The all three B's are we are taking here k and G is only are taking P. Already I told P plus Q is equal to 1. So therefore Q is equal to 1 minus P. We will write the formula. So therefore the fundamental formula where Q is equal to 1 minus P is equal to Q power Kp. We have suppose birth or independent, we have motivated. What is the concept of geometric distribution? The geometric distribution in statistics a discrete probability distribution. The continuous distribution means the numbers it should be continue. The discrete probability distribution that describes the chances of achieving success in a series of independent trials, each having two possible outcomes, that is head and tail. The geometric distribution thus helps measure the probability of success after given number of trials. See the graph. P is equal to 1 by 6 probability of the first three of each note of this one, p is equal to 1 by 6, we are taking the graph, we are taking the values here. What is the characteristics? What is the characteristics of the geometric distribution? Here, there are three characteristics of geometric experiment here. There are one or more Bernoulli trials. One or more Bernoulli trials we are taking here with all failure except the last one, which is a success. 3 means 2 is failure and 1 is success. So in the theory, the number of trials could go on forever. There must be at least one trial. In the geometric distribution, there are the parameters also is there. What are the parameters of the geometric distribution? The parameters of geometric distribution, we will consider two parameters of geometric distribution. What is the two distributions? Mean and standard deviation. What is the mean? Sagatu. Standard deviation, Vistruti. So the mean means in general what we have taking 1 plus suppose 0 to 10 they given that number of that if the 10 numbers is given number we can sum it and by division by 10. This is the average number of failures before the first success. The mean of geometric distribution is the same as the expected value. Why is geometric distribution is called as geometric? The distribution is called geometric because the successive terms of the probability function described above form a geometric progression with a ratio q. What is the shape of geometric distribution? The shape of geometric distribution is always skewed to the right, indicating that the number of trials increases. The trials means the failures are increases. The chances of needing that may trials for the first success decreases. That means the trials are one success and immediately coming to the trials, the many trials for the first success will be, we know that it should be decrease. What is geometric probability density function? PDF means probability density function is used. Here geometric probability density function represents geometric probability density function. It is used to find the probability that geometric random variable is equal to an exact value. See here, the geometric random variable is exact value. Why? Because the random value we can take here and we can substitute, we can take in the probability density function, it should be the equal and an exact value also may become here. P is the probability of success and number is the value. So 1 P plus Q is equal to 1 we have told here. What is an example of a geometric distribution in real life? The geometric distribution is used when you need to count the number of tries until you get a success in experiment. Suppose we can head and tail and tail and tail. So success on experiment, for example, flipping on a coin until you get heads, rolling a fair dice. If a coin dice is a head and tail, so fair dice until you get a certain number, buying a lottery ticket until you get a prize. So the lottery ticket, where we are taking the buy and buy lottery tickets, we can get it here at one of the time we can or success or loss, but we can earn or not, we can take that one, we can buying that tickets, but we can do it, we are hoping that we can win the prize with the lottery ticket. When use a geometric distribution, if you are interested in the number of trials, need to be obtained the first success. Use the first kind of geometric distribution. If you are interested in the number of success, you are able to achieve before the first failure. I already told you, you are interested in the number of success, you are able to achieve before the first failure. Accuracy, use the second kind of geometric distribution. So first failure and second failure, immediately we have to do, we can go to the success of the point. How to find the mode of geometric distribution? The mode of geometric distribution is 1p minus 1 by minus 1 log 2 into 1 minus p, or 2 minus p or 1 minus p. We can do anything here. The geometric distribution what p plus q is equal to what we are substituting the values here. So almost we are taking the values of 3, 1. What is the variance of geometric distribution? So what is the, already we told that mean, now variance we are taking here. So variance of the geometric distribution, for a geometric distribution, the variance indicates the variability in initial failures, but about the exception and acceptation. The formula for the variance of geometric distribution sigma square is equal to 1 minus p square. What is the average of the geometric distribution? Already I told that is q is equal to 1 minus p. What is the parameter of the geometric distribution? The geometric distribution is one parameter of family of curves that models the number of failures before one success. See here the number of failures before one success in a series of independent trials. స్వతంత్రంగా ఉంటాయి. So which are each trial result in either success or failure, and the probability success any individual trial is as constant. This is the basics of the geometric distribution. In the real life, and how to will continue, mean, standard deviation and variance we have learned here. Now what is the moments of geometric distribution? What is the moments? Bhramakalu. The moments of geometric distribution can be obtained as here. The rth moment. What is the rth moment? R1, R2, R3 and until rth moment origins mu1, mu r dash, that is ex power r. So in the geometric distribution ex power r is equal to summation of x is equal to 0 to infinity. Suppose we have to taking the value from the beginning x is equal to 0 to until we have to taking infinity x power r, that is p x is equal to small x, where p x is equal to x is a probability mass function that is called PMF in geometric distribution. The fundamental formula mu r dash is equal, suppose mu r1 we are taking, see all of you here, mu dash r, ఇంతకుముందు మనం mu r0 తీసుకున్నాం, 1 తీసుకుంటున్నాం, ఇక్కడ summation of x is equal to 1 to infinity x power r p into q power x. Suppose r is equal to 1, we are substituting here. Suppose mu1 dash is equal to e power x, summation of x is equal to 1 to infinity x into p into q power x. So p is a constant, I am taking in front of sigma, p is constant, taking one side, p into summation of x is equal to 1 to infinity x into, so 1 plus p, p plus q is equal to 1, so therefore I am writing here q into x power minus 1 into q. So pq, again enlarging the expansion here, 1 plus 2q plus 3q square plus 4q cube plus 5q power 4, అంటే నెంబర్ పెరుగుతున్న కొద్ది పవర్ పెరుగుతూ ఉంటుంది. సో we are simplifying 1 plus 2q plus 3q square, that is we are simplifying in the next step. Pq is a constant as is easily here, that is when we are taking here the upper step 1 minus q whole power minus 2. So pq as easily there, I already written here p plus q is equal to 1. So pq into p power minus 2, p is equal to 1 minus q, so that is almost already power, in the power is minus 2 is there, I am writing p power minus 2. See here, so p power minus 2 in the denominator part, pq by p square, so it should be divisible, mu1 dash is equal to q by p. So it is a proof e of x is equal to mu1 dash is equal to mean, that is q by p. The mean of the geometric distribution is q by p. If r is equal to 2, the we are taken earlier the one value, now we are taking r is equal to 2, so mu 2 dash is equal to e of x square, summation of x is equal to 1 to infinity, we are taking x is equal to 1 not 2, x square into p of x is equal to x, mu 2 dash is equal to summation of x is equal to 1 to infinity x square into p of x is equal to x. See here I am expanding this one, summation of x is equal to 1 to infinity p x into x minus 1 plus x. So minus and plus should be cancelled, the values should be the same here into p of x. Summation of x is equal to 2 into infinity x into x minus 1. Then in place of x we are writing here p of x into summation of x is equal to 1 to infinity into p of x. Summation of x is equal to infinity x into x minus 1, we are writing p of into x, summation of x is equal to 1 to x into p power x. The simplification from equation number 2, p into q power x plus p by q. Simplification, 2 into pq square, that is summation of x into 2 infinity x into x minus 1 by 2 factorial into 2 into 1, then q into x power minus 2 plus q by p. Simplification, 2 into p q power 2, expansion of the above equation, summation of x is equal to infinity x into x minus 1 into 2 into q power x minus 2 plus q by p, expansion I am writing here 1 plus 3q plus 6k square plus 10q and so on plus p by q. So 2p square, 2pq square we are writing above the equation, we can ఇంతకుముందు 1 minus q whole power minus 2 రాసాం 0 ఉన్నప్పుడు. సో ఇక్కడ 2 ఉన్నప్పుడు 1 minus q whole power minus 3 plus p by q. So 2pq square into 1 by 1 minus q whole cube పవర్లో మైనస్ ఉంది కాబట్టి డినామినేటర్కి వచ్చేవారు ప్లస్ అవుతుంది, ప్లస్ క్యూ బై పీ. సో 2pq² ఇంటూ 1/pq ప్లస్ క్యూ బై పీ మ్యూటు డాష్ ఈజ్ ఈక్వల్ టు, మనం డినామినేటర్లో కట్ చేస్తే p² కట్ అవుతుంది కాబట్టి ఇక్కడ డినామినేటర్లో p² ఉంటుంది, 2q² ప్లస్ క్యూ బై పీ. We know the formula of mu2, e of x² minus within the brackets of e of x whole square, that is variance of x v of x, that is equal to mu2. What is the mu2 formula? We know the mu1 formula, mu1 minus mu1 dash is equal to 0. So here mu2 dash minus mu1 dash whole square is equal to, this is a basic fundamental formula. I am writing here 2q² plus q by p minus q² p² is equal to, the simplification I am doing here, q² plus q by p. After LCM and after the numerator and the denominator, the value should be remaining moving. After the value getting here, q by p². The variance of the geometric distribution is q by p². Moment generating function of geometric distribution. Let x be a random variable. Then its moment generating function is given by m of xt is equal e into e power tx. So m of xt in మనం ఏం రాస్తున్నాం, summation of x is equal to 1 to infinity e power tx into p of x is equal to x. See here e power e tx ని మనం summation of x is equal to 1 అప్లై చేస్తున్నాం, e power tx into p into x is equal to x, where px is equal to x is a probability mass function. Already you know that PMF is a geometric distribution. M of xt, summation of x is equal to 1 to infinity e power tx into p into q power x. The fundamental formula we are taking here, p summation of x is equal to 1 to infinity e power t into q. See here above the formula e power tx into p into q power x, p is the taken the common here. So p taken here e into t into q, both the power x is common there, so I am taking the base e power t into q, taking the whole power x I am taking here. So m of xt, so p is the constant of the earlier above the formula, p into e into t, e into 2 into e power t into q whole power x, we are writing here p into 1 minus q into e power t inverse. This is the first one. Now differentiate equation number 1 with respect to t. Put is, what is the differentiator? Differentiate means mu1 dash dy by dx atla chestam, mu1 dash d by dx d by dt of, why we are taking t, అందులో t అనే ఫంక్షన్ ఉంది కాబట్టి we are d by dt of m of x t, put t is equal to 0 కాబట్టి t is equal to 0, d by dt of, so formula m of x t earlier మనం అనుకున్నాము, p into 1 minus q e power t whole power inverse t is equal to 0, p into 1 minus q e power t whole power minus 2, దాన్ని డెరివేషన్ చేస్తున్నాం, డెరివేషన్ చేస్తేనే x power n minus 1 by n minus 1, so whole power minus 2 by q into e power t, the condition t is equal to 0. p into the condition is 1 minus q whole power minus 2 into q, you know that e power 0 is equal to 1. pq, so p into q అవతల వైపు ఉంది, దాన్ని ఇటువైపు తీసుకొచ్చాను, 1 minus q, we know that p plus q is equal to 1, so 1 minus q in place of 1 minus q I am writing here p into q into p whole power minus 2. So e of x is equal to mu1 dash is equal to p power minus 2, denominator తీసుకొస్తే p స్క్వేర్ అవుతుంది, the cancellation of the values చూస్తే q by p. The mean of the geometric distribution is q by p. Again e of x square mu2 dash d square by dt square m of x t is equal to 0. We are taking this number 2, we are taking here d by dt of, again derivating d by dt of m of x t. First derivation again we are derivating, the second derivating we are taking d by dt. d by dt of m dash x t, so d by dt of, the first derivation is pq into e power t. What is the first derivation value? 1 minus q into e power t whole power minus 2. It is equal to 0. So what is that second derivation I am doing here? P is the constant I am taking here, q into e power t, 1 minus q into e power t whole power minus 2. Again is the chain rule we are taking here, plus q into e power t, మళ్ళీ దాంతో చేస్తే 2 into 1 minus q into e power t whole power minus 3 into q into e power t. T is equal to 0, we are substituting here. Therefore, p constant as clear as q into 1 minus q whole power minus 2 plus 2q square 1 minus q whole power minus 3. P by, that is q into 1 minus q whole power minus 2, that is we can write here q by p square by the simplification. 2q square minus 1 minus q whole power minus 3, we can write 2q square by p cube. Therefore, mu 2 dash is equal to q by p plus 2q square by p square. What is mu 2 value? This is the derivations of the first one and second one. We have to do here e of x square minus e, within the square brackets e of x whole square. So, mu 2 is equal to mu 2 dash minus mu 1 dash whole square. This is the mu 2 formula. In central moments, we have mu 1, mu 2, mu 3, mu 4. We are finding out in here that mu 2 is equal to q by p plus 2q square by p square minus q square by p square. After simplification, that value here q by p square. Hence, the variance of the geometric distribution of the mu 2 here q by p square. What is the remark of the mu 2? P is equal to 1 by q and q is equal to p by q. But denominator should not equal to 0. The denominator should equal to 0, the value is 0. The denominator should equal to 0, we cannot do anything. So, then m of xt is equal to q minus p into e power t whole power minus 1. So, therefore, p is equal to summation of x is equal to 0 infinity sq whole power x. So, therefore, p, then simplification 1 plus qx plus q square plus x square plus q cube s cube and so on. We are writing here p of s is equal to p into 1 minus qs whole inverse, which this is required probability generating function of the geometric distribution. Now differentiate, now we are differentiating this one also. Mu 1 dash is equal to d by ds of p by s. P by s means what is the p of s? What is the p of s earlier? That is 1 minus qs whole inverse. P into 1 minus qs whole power minus 2 into qs. Now we are putting s is equal to 1. So, p into 1 minus q whole power minus 2, we are s is equal to 1, p q into s 1. So, s is equal to 1, therefore, q into 1 is equal to q. So, therefore, p q atlane multiply chestam p into q, 1 minus q whole power minus 2, that power minus 2 in the numerator, it's come to the denominator, we can write here 1 minus q whole square. So, therefore, p q by 1 minus q, know that is p square, it is q by p after the simplification. What is mu 2 dash? That is q by p. Mu 2 dash is equal to d square by ds square, that is p of s. Again we are derivating the same here, d by ds of d square by ds square into ps. The second derivation, just we are know that mu 1, mu 2 we are finding here, then we can find here mu 1 dash and mu 2 dash also. D by ds of pq, s into 1 minus qs whole power minus 2. Again derivation, pq into 1 minus qs whole power minus 2 in the chain rule we are doing here, s into minus 2 in the mana 1 minus qs whole power minus 2 power lo minus 2 ni kindi తీసుకొస్తున్నాం minus 2, then 1 minus qs, the formula is x into n into x power n minus 1. So, 1 minus q into minus 2 of minus 1, that is minus 3. Again minus 2 should be removed, 1 minus qs, the 1 is constant 0, then we are writing minus of qs here. Then pq 1 minus qs whole power minus 2, then simplification of this one, 2s square q, that is, and 1 minus qs whole power minus 3, that is a constant, should be 0. Put s is equal to 1 we are taking here. Then pq into 1 minus q whole power minus 2 plus 2q into 1 minus q whole power minus 3 above formula. That pq 1 minus q whole power minus 2, that is 1 minus q means p by that by 1 by p square plus 2q by 1 by q, 1 minus q means p by p cube. We are writing here in the denominator, that is after the simplification of this above formula, pp should be cancelled here, therefore q by p plus 2q square by p square. What is mu 2? Mu 2 dash minus mu 1 dash whole square is equal to q by p plus 2q square by p square minus q square by p square. We are writing q by p whole square also, that is equal to q by p square. Now let us do some problems here. Let x the number of days until the closing price of certain stock shows gain over the previous day closing price. అంటే నేను స్టాక్ ఎక్కడ క్లోజ్ అయిందో మనం తెలుసుకోవాలనుకుంటున్నాం. అజ్యూమ్ దట్ x is a geometric random variable with P is equal to 0.5, the probability of a gain in the price from one day to the next day. ఇవాళ ఎక్కడ క్లోజ్ అయింది, రేపు ఎక్కడ చూద్దాం. Find the mean and the standard deviation of X. Find the probability that more than 2 days pass before again price from one day to the next day is observed. See here, you know that P plus Q is equal to 1, P is equal to 0.5. So P plus Q is equal to 1. So Q is equal to 1 minus P. 1 minus P minus 1 minus 0.5, again that is 0.5. Then mu is equal to 1 by P. 1 by P means 1 by 0.5 is equal to 2. The variance, that is sigma square Q by P square. Q is 0.5, that is P is 0.5 into 0.5. That is, we are multiplying that by 2. Standard deviation sigma, that is sigma under variance of root 2. See here all of you, what is the mu, what 1 by P and 1 by 0.5, we are absolutely substituting the value and mean and variance. Standard deviation sigma, what is the variance here, under root of 2. We are substituting the root 2 and we can find the value here. Find the more than 2 days, pass before again price observed is given by P x greater than 2. So x greater than 2 is a different, x greater than or equal to is a different. See here, x greater than 2 we are taking here. So now we are right here 1 minus P x less than or equal to 2. Up to 2 we are taking the values here. See here, that is 1 minus P x is equal to 1 and P x is equal to. Suppose we x less than 2 or x greater than 2. Suppose we are taking these two values, x greater less than 2, we are taking P x is equal to 1 only. So 1 minus 0.5 whole inverse into 0.5 plus 0.5 whole inverse 2 minus 1 into 0.5. We can write here 1 minus 5, 0.5, that is after simplification of the above value 0.5 plus 0.25. So 0.25 plus 0.5 after the 1 minus after the simplification here, that is 0.25. Another example we can take here, if a production line has a 20% defective, అంటే line లో 20% defective ఉంది, problem ఉంది. What is the average number of inspections in the first defective? First defective లో ఎంత inspections ఉన్నాయని చూద్దాం. P is equal to given 20% and 20 by 100, that is equal to 0.2. Already know that P plus Q is equal to 1, Q is equal to 1 minus P, 0.2 1 minus 0.2 is equal to 0.8. Mean of the geometric distribution, you know the formula of Q by P is equal to 0.8 by 0.2, that is 4. Therefore, average number of inceptions obtained the first defective is 4. For certain, another example we are seeing here, for certain manufacturing process, it is known that on the average 1 in every 100 times is defective. Average lo 1 lo 100 item lo kutundochu. What is the probability that 5th item inspected is the first defective item found? 5th item lo the first defective item etla we can find chestam. Using the geometry distribution x is equal to 5 and p is equal to 10% కాబట్టి 0.01. We have geometric distribution g x comma p g 5 0.5 అన్నాం కాబట్టి 5 లో 0.01 ఎన్ని తీసుకుంటాం 5 తీసుకుంటున్నాం కాబట్టి ఇంటూ p 0.99 ఎందుకంటే తీసేస్తాం కాబట్టి అందులో 100 అన్నాడు కాబట్టి 100 మైనస్ 0.01 అన్నాడు కాబట్టి 0.99 5 minus 1 0.01, that is 0.996. At a busy time, the telephone exchange is a very near capacity. Callers have difficulty placing their calls. It may be of interest to know the number of attempts necessary to make a connection. Suppose let we 0.05 the probability that attempts are necessary for a successful call. See here, this is also same. Geometric distribution x is equal to 5, q is equal to minus 1, that is 1 minus p, 1 minus 0.05. We have geometric distribution g x comma p. So indulo kuda same 0.95 minus 5 minus 1, that is 0.01. The preposition, suppose x has a geometric distribution with parameter p, e of x is equal to q by p, variance of q by p square. This is a fundamental formula we are writing here. What is the PDF of geometric distribution? Know that probability density geometric distribution with the parameter p is the evaluated value at n. Also, you know the standard of geometric distribution. What is the summary in this unit? In this unit, we have discussed the interaction of geometric distribution and obtained the moments of the distribution, derived the moment generative function of the distribution, and also we have solved so many example problems in the geometric distribution. In the geometric distribution, this is a theoretical part. Next class, we have to discuss in the applications of the geometric distribution. You have to learn and practice all these one. Thank you one and all.